This is Graphing Systems from Point Slope to Slope Intercept version 1. I'm going to be doing number 1 as we did on the board. Here we go. We have our equation y plus 1 equals negative 5/3 times the quantity x minus 3. The first thing that our directions say to do is to graph. So we're going to have to pull out an xy point. This is y1, this is x1. When we pull our point out, we're going to have to do the opposite. So instead of negative 3, we're going to pull out the x to be positive 3. Instead of positive 1, we're going to pull the y out to be negative 1. And that's that first point that we're going to graph. We're also going to have to graph the slope, or actually we're going to have to do the slope. There's a negative. I'm going to give it to the 5, so this means I'm going to be going down. The 3 is positive, so I'm going to be going right. So let's graph this first on the graph here. So my point again was 3, negative 1. So I'm going to go to 1, 2, 3 on the x and negative 1 on the y. So there's my point, 3, negative 1. And then my slope, let's remember, was down 5. 1, 2, 3, 4, 5, and right 3. 1, 2, 3. Now we can also go back to that start point. We can go up 5. 1, 2, 3, 4, 5, and left 3. 1, 2, 3. That gives us a nice long line, and we know exactly where everything matches up. Okay, so we graph that line first. Now what we're going to need to do is part B, put in slope-intercept form, solve for y. So we're going to have to solve for y. I'm just going to block this out because we don't need it. So I'm going to write down y plus 1 equals negative 5/3 x minus 3. Remember, when we solve for y, we have to get rid of the parentheses, meaning we're going to have to distribute that negative 5/3. So bringing down my y plus 1, the line here, equals negative 5/3 times x is negative 5/3 x. Negative 5/3 times negative 3 is a positive, because negative times a negative is a positive. 5/3 times 3 over 1 gives you 5. I'm not done yet because I still have this plus 1 that I need to move over to the other side of the equation. I do that by subtracting. Y equals negative 5/3 x plus 4. Here's my equation now in slope-intercept form. That was part B. Part C, we have to graph that equation, this one in slope-intercept form, on the same set of axes. So the graph that I just used down here, I'm going to have to plot this one. So let's take out our y-intercept, which is that positive 4. So that's our start point, is our 0, 4. And then let's take out our slope, negative 5 over 3. Again, down, I gave the negative to the 5, and this is positive, so I'm going to go right. So again, let's review start point, 0, 4, the y-intercept, and our slope, negative 5, 3. Down to the graph, we're going to go to 0, 4, 0, 1, 2, 3, 4. Notice it is a point on our original line. So here's our start point, 0, 4. From our start, we're going to go down 5, 1, 2, 3, 4, 5, and we're going to go right 3, 1, 2, 3. I got another point. Let's make it a little bit bigger. I can do that one more time. 1, 2, 3, 4, 5, 1, 2, 3. Another point. And if you would like to go to the opposite direction on the y, we can go back to 0, 4 and go up 5, 1, 2, 3, 4, 5, and left 3, 1, 2, 3. It actually extends this line a little bit more. And we see we're actually getting the same line. All of our points are matching up. So I'm just going to redraw this line. Now I'm going to put double arrows to show that we have the same line. So we have two equations that look different, one in point-slope form, one in slope-intercept form, but when graphed, we have the same line. If this were to be considered a system, we would be having infinitely many solutions. All points we can use, we would be able to substitute into these two equations, and they would make both equations true. And there you go, graphing systems from point slope to slope intercept.